Hello guys, welcome to the civil engineering YouTube channel. Please subscribe our channel for more civil engineering updates. Right, so today our topic is about the singly and doubly reinforced concrete beam, that why we use the doubly reinforced beam and when we have to use the doubly reinforced beam as well as the singly reinforced beam. As we in practice, we are mostly use the singly reinforced beam, but in some conditions we have to go to doubly reinforced beam. So here we will discuss that when and why we use the doubly reinforced beam, right? So coming to the introduction of the singly reinforced beam, for example, I'm taking a beam. It is simply supported beam. Let's suppose it is simply supported beam, right? And I'm going to show its cross section. I'm drawing it like a Z with the height of the beam. I show it here, and let's suppose this is the beam of any length, length L, and I have show its cross section, right? It here, yeah, cross section AA. So I will show its section here like that. AA section A. Right, there is a section of this beam, cross section of this beam, and we here have for example, I'm taking an example that we here have only number 8 bars, right? And I'm drawing it here by a line length because this is not the cross section view, but this is the we can say longitudinal. We see the longitudinal bars in this direction. We can see the front view, or not the front view but the elevated view, right? And now I'm show here these are number 8 bars, right? So I will, for example, these are the longitudinal bar 8 are the number of bars, and number 8 bars are used, right? So I will show it here that this is the number 8 bars, 1 2 3 4 5 and 6 and 7 and 8, right? And there is demand coming on this beam, right? For example, this any demand coming on this beam is MU, the effective demand, right? Effective demand is coming on this beam, and we place the reinforcement, and this reinforcement should be able to resist this beam. Now, for example, the moment capacity of this beam is M1, right? So we have to if the moment demand is coming on this beam is less than the M1, the moment capacity of this beam. If you guys didn't know about the design of singly reinforcement beam, so we did it in before the videos, and you can check in the description of this video, or you will find the design of singly reinforcement beam. So you will get to know how to find the M1, and we have designed the singly reinforcement beam. Now I'm going to define the doubly reinforcement, then when we have to use the doubly reinforcement beam, right? So is it take an example that if MU is the demand coming on this beam, load coming on this beam MU, and the M1 is the capacity of this beam, right? This is the capacity of this beam M1, while this MU is the demand of the load coming on this beam, the demand, and this is the resistance. So in this case, if the demand MU, right, I'm writing it here, if the MU is greater than M1, right, when the capacity of the beam is less and the moment demand is more, so this beam will definitely going into deflection case, and it will be broken up. Why? Because the moment demand is more and the capacity of this beam is less. So what should we do here? We should do, if we have some restriction on the beam head of the room or something else restriction, height of the beam, if we don't allow to increase the height of the beam edge, so what we should do, we should go into the doubly reinforcement beam, in which we have to also place the reinforcement in the top of the section beam like this. So for example, I put here 4 bars, 4 number 8 bars, right? 4 number 8 bars I also put in the top of the beam. So we call it now it's doubly reinforcement beam, because the capacity of just the single reinforcement beam was not able to resist the demand. So we put the bars, any number of bars, the number of bars will come from the design of the beam, right? So according to that, we will find the number of bars, and we find, for example, that 4 number 8 bars are coming. So we will show it here, 1 2, 3, and let's suppose 4. So we see that the four number of bars are coming in this way, right? While you have to provide must these two number of bars, right? These are for the confinement bar. We can say confinement bar, but these two number of bars must be provided to hold these stirrups, right? These two bars, while the 4 is a whole, we can say they are done with the 4 number bars. So these are now sufficient to resist the moment demand. So now M2, let's suppose I'm giving an example that M2 is the capacity of this doubly reinforcement beam. Now it is called doubly because the reinforcement is now provided at the top as well as at the bottom. So when the reinforcement is provided in the top, in the bottom as well as in the top, we call it the doubly reinforcement beam, right? For example, taking the capacity of this doubly reinforcement beam is M2. So now we can say that the capacity of this beam will be equal to M1 plus M2, right? M2. So now these two capacities like M1 plus M2, this should now be greater than MU. If this is greater, so it's okay. Your beam is now going to support this demand and it will be okay. It will be fine to resist this demand, and there will be no destruction in the beam or in the structure, in the structure you design. So this was all about the double reinforcement beam. Then when we should provide, and we provide when the moment capacity is less than the demand. So we are going to design the doubly section as well, and which we have designed the second reinforcement beam in our previous video. You can check out by clicking on the description below, or you can visit our channel. You can find the design of single reinforcement beam, complete design of single reinforcement beam, right? And if you have any question, please comment. We will respond to you. And please subscribe our channel for more civil engineering updates. And thank you for watching our video.